In this video, we'll be looking at ions, in particular, how to write formula. Now here's a few things we need to remember. Starting off, the ionic compounds we're going to look at are always going to be made of a metal and a non-metal. The naming rules, which we had a look at a previous video, will always work for these two, and they'll help you identify what elements are present. Now there'll still be certain ions you are going to have to memorize, and knowing the ionic charge is going to be really beneficial to working out the entire formula. Now here's a few rules. Rule number 1, we always need a positive ion as well as a negative ion, and these form our ionic compounds. The overall charge of an ionic compound will have to be neutral, so have to equal 0. And lastly, you can always have multiple of a particular ion. Okay, so here's our first example, sodium chloride. Now, as we have done previously with our bonding, the first thing I'm going to do is split this up. I have sodium and I have chloride. The ion charges, again, we can use our periodic tables to figure these out for our simple ions. So sodium is going to be +1 and chloride -1. And then we're going to use a method called the drop and swap. So if I just take that chloride, I'm going to use the number on the opposite ion to tell me how many of those I need. In this case, chlorine, and the opposite number, sodium, has a 1, so I need 1 chlorine. And I'll do the same thing with sodium here, where the number on chlorine is 1, so I need 1 sodium. And then we just need to simplify this down. Now in chemistry, we're quite lazy. We don't really include the number 1. So we'll simplify this down to NaCl. And here's those common ions I was talking about previously. These you are going to have to memorize, unfortunately, but with more practice, it becomes a lot easier. For our next example here, we've got magnesium hydroxide, and we'll follow the same steps we did previously. So we'll split this up into magnesium and hydroxide. The charges, well, magnesium's a metal in group 2, so it'll be +2, whereas hydroxide is one of those common ions which I mentioned earlier, and its charge is -1. Now we'll drop and swap. Now if we start off with hydroxide, we're going to have 2 lots of these because magnesium has a +2 charge. And pay close attention to these ions here. We've put them in brackets because I need 2 lots of the entire hydroxide. And then magnesium is going to be 1 because hydroxide has a -1 charge. And then if we just simplify this down, again, we'll remove any 1s here, where we'll be left with MgOH2. And just pay close attention here to the charges. The total charge is going to equal 0. Magnesium's +2, and I have 2 lots of hydroxides, each one with a -1 charge. Therefore, it's a total charge of 0. Right, here's a few for you to try yourself. Now, with these next 8 examples, take the next 5 minutes to work through them. And if you need any help, just go back to those examples. Otherwise, skip ahead if you finish early, and I'll see you in 5. Right, let's see how we've done. Here's the answers to those questions. Okay, now let's summarize what we've looked at. Starting off, the overall charge of an ionic compound must equal 0, and this means the charges are balanced. Opposite charged ions tell you how many you need of that particular ion, and you have to remember those common ions. These I'd recommend flashcarding and then just going through when working through questions. Right, I hope this video has helped. As always, if you have any questions, just leave them down below and I'll do my best to get back to you.